Alright, what's up, dudes? So we're back. Went and got my teeth cleaned. Ate dinner. We're gonna do a little more coding, okay? Trying to get like ahead while I'm out of work right now because I'm not working. Currently, I'm on leave, so short-term medical leave. I still get paid 60%, so still getting paid a little bit, which is good. But since I'm not like spending hours working, it feels a lot easier to spend more hours coding, you know what I mean? And plus, we hit a little breakthrough here with this bug, one of these bugs that have been around for a while. Finally got around to addressing it, and we've actually implemented a solution. First, I do want to enter in this test segment though, because I forget that you can't use the values or keys method on a dictionary. You will get a type error. Object is not subscriptable because it doesn't return a list. It returns a view object, which is very strange, honestly. Like I'm not sure what a view, like what is the purpose of a view object. Actually, I'm gonna ask Chibbity Jibbity what the purpose. What is the purpose of a view object? Just in the context of data structures like lists or dictionaries, a view object typically refers to a dynamic view of the data. The main purpose of the view objects include dynamic representation. View objects provide a live view of the original data. Any changes to the underlying data structure are reflected in the view. For example, if you modify a dictionary, the view object of its keys or values will automatically update to reflect those changes. No, this is this is big. Wait, because I'm like pretty sure that if you were to hold up, dude. If you were to say E equals D, okay? And then we said D at C equals 3, okay? And then if we print E, okay? What are we gonna get here? I'm confused. Oh, okay. So that's why. All right. If trying to think of a way to word this precisely. So all right. Let's see. Let's do D at C again, okay? Equals 4. And then let's print E again. What's happening here? Okay. Well, okay. What if we then the reason I'm wondering about this view object thing is because I thought there was instances where you would assign a key value pair to a dictionary, okay? And then like depending on maybe immutability, like okay, let's say let's try this. So we'll make a list 1 2 3. We'll say D at C equals L. Okay. And then if we print E, it should include that list, okay? But then if we modify 4 to that, and then we print E again. Okay, so that does get reflected. Now, if you were to say okay. Okay, see, this is what I was talking about. Alright, so we reassigned C.L. Now, I don't know if the view would fix this, because this was my question. Like, see how we reassigned CL to a new list, but even though D at C is equal to C.L, when we print E the first time and the second time, it has the C key with the 1 2 3 value. After we reassign C.L, E no longer references what C.L was, currently is rather. And I wonder if a view would change that. I don't think it would. So I'm just wondering, like, what is the purpose of the view versus like the actual dictionary? You know what I mean? So now let's do print E.keys. Okay, so it's really to keep track. I see now. I think it's to keep track of. It's like an object that refers to the current keys or values of a dictionary. So the dynamic representation, they provide a live view of the original data. Any changes to the underlying data structure are reflected in the view. For example, if you modify a dictionary, the view object of its keys or values will automatically update to reflect those changes. Okay. View objects can be more memory efficient than creating a full copy of the data. Since they refer to the original data, they do not require additional space for duplicate data. Yeah, but you can't. Well, yeah, you can. You just have to turn it into a list. But once you turn it into a list, it's no longer live, right? So that's cool. I see now. So really, what a view is for, if we had something like this. So we have A and B in a dictionary, and then we create D keys view equals D dot keys, and then if we do D at C equals 3, and then we print D keys view, we would get that C it updated. And then if we add another one at D for the value 4, oh yeah, we have to print again, duh. And then we print it again, we would get the D key. And same thing with values. If we created, let's see, the same thing here. I'm just going to change this to be values. And then we're going to print that. And then we will print it again. And it will update, so it'll be ABC 1 2 3, ABCD, and then 1 2 3 4. Even though we assigned it once, it's not like a regular variable, you know. If we just created like a list of the keys, it would only create that at a point in time. Offers live view when updating, when making future updates. Alright, we can just say reflects future updates, which is really cool. And I didn't know that, and now I know. Now I know the purpose of a view. So we'll call this dict keys values view live update rule. That was a little lengthy. Anyway, a reminder that dict dot keys and dot values returns a view object which offers live data if you update the keys values of the dict, the view will reflect those future changes after view assignment. Alright, yeah, no, it was worth it. Anyway, we're gonna go back to main thing. It's gonna be menting this last bit. Well, last bit for the day, that is. So we created in things to do, I believe, some pseudocode, and we're gonna review it really quick and make sure it's correct. So we have the click card logic. So we need to fix the logic associated with lines 94 blah 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 blah. We just are looking at the pseudocode. Alright, here we go. So we have for current card in self clickable card list, card top list append card rect top. Then we get the min card top, which is the min from the list, and then the max card top difference equals max card top minus min. Okay. If card top difference is greater than or equal to vertical stack card top difference, the actual difference in pixel value between 2x cards stacked vertically. Yeah, so if we have well, what if we have both though? What if we have vertical and horizontal? Like, I know sometimes well, if we went off of the collided cards dictionary first though, that would solve that issue, because we would have like, let's just say we had 10 cards in the clickable card list, and in this case we had, it was like 3 different melds where we were being asked to add a wild card to it. If we had 3 vertical stacks, well that would be 3 vertical stacks, but we would also have horizontal, they wouldn't be stacked per se. Yeah, we wouldn't want to go off of like the clickable cards. All that we care about is determining which card we clicked, right? That's all that code, like the code we're working with, we're trying to create, is to determine the proper card that we clicked. And whenever you click any given like card group or whatever, it's either gonna be like a vertical set or a horizontal set. I don't think there would ever be an instance where you would have both. You know what I mean? Yeah, I don't think we would ever have a problem with that. Um, so we actually want to change this. We don't need the iteration through the entire clickable card list. We just need iteration through the cards from the clickable card list that ended up in the collided cards dictionary. So yeah, all we would do here on this line, and this would apply to both of these sections because we have two different sections here. As a matter of fact, I want to bring this over to the actual file, the Python file, because writing that out without being able to see the coloring really is throwing me off here. So here's what we're gonna do. We're gonna separate this, go to the proper indentation level. Okay, and then let's compare here. So this would stay the same for card and clickable card list. If rect card rect collide point event position click card true. Yeah, this would remain the same. Well, except for this line right here. That line would get moved. So here's what we're gonna do. We'll get rid of this. Card top list append. Card top list. So this is going away. And we're gonna put this somewhere else. So this is gonna get put somewhere else as well. And all that's gonna happen how about this? We could create a list of collided cards, right? Or we could make the key be the X and then the Y. Because in the one instance, for the vertical stack, we would be going off of the Y. Well, no, all we really need to do is do one iteration through the clickable card list that appends to the collided cards dict. So let's try this a different way. Let's undo all this. Okay, before we added this code in. And then I can go back here, undo this code because I have to put it back here. Alright, so let's leave it like that. Let's go back here, get rid of this. And then how did this, okay, there we go. Alright, now we want to copy from, basically we'll just copy this entire if right here. All that. But where do we stop at? Okay. Basically right here. I think this is where we would want to stop. So we'll copy this. Bam. And now we're gonna actually messed up here. What I need to do is comment this out. So it's really just this section right here. That wouldn't change. None of that would change. Click to card. And that wouldn't change either. It would be this that changed. So this is going to get commented out. And just because I will include this line because it goes with it. I will div this out. Paste that in. Alright, let's put our new div up here. Being replaced by above section, leaving until I am 100% sure the code is valid. Alright, so we get, well, we don't have to get rid of this. We'll leave the div, copy that one, paste in another one, and then what we're going to do here is we'll copy this code and then we're going to modify it. So we'll put it here, uncomment this, make sure we add in a comment. Let's just say replacing below section. Okay. Now we can go ahead and change it. So we would do for card and clickable card list, card rect collide point event position. Okay. Now this is gonna go away. This is gonna get put in its own section. So we'll separate that out. And then I feel like I could just use a list. Like I don't know if I need a dictionary. Let me just try and use a list instead of a dictionary, because I would have to have the key to being like multifaceted depending on the logic we wanted to we're gonna go with. But before we make that determination, we still have to have a way to access those collided cards. So I think it would be easier if we just did something like this, where we said collided cards list. Just have an empty list, and then we would append to that list collided cards list append, and we would just append that card straight up, just like that. So if we collided with the card and it was in a clickable card list, we change click to card to true, and we would then append that card to the collided cards list. Cool. Next, after we're done with that iteration, then we can determine, let's say, let's copy this, and let's specify that this section populates collided cards list if yeah, we don't even have to describe that. Okay, now we have a new section right here, and then we're going to iterate through the collided cards list. And I'll put a note here that we may not need that dict anymore. So I don't forget to do that. Now we can add in that code from this section over here that we created right here. All this pseudocode. Bring it in. Go back over here, and we'll paste in this new code. Right. So this line is gone. We're not actually going to do that. Now we're going to create this card top list. Right. list. And then we're going to append the rect.top of each card in the collided cards list to this card top list. Okay. Then when we're done with that iteration, we're going to get the min card top, which is the min of the card top list, and then max card top is going to be the max of the card top list. So we're going to get the value, highest value, and this is if the length of collided cards list is greater than 1, right? I mean, or greater than 0. We would want this to happen when it's greater than 1. Because if it's only equal to 1, then we could simply we don't have to determine from multiple cards which one was the click card. Like, we already know what the click card is. So we only would do this if the length of the collided cards list is greater than 1. Okay? So this should actually be indented to here. So we have the card top list. We iterate through the collided cards list. And we append to the card top list each card rect top. Then we get the min card top, which is the lowest. Okay, that would be visually the lower card. And then we get the max card top, which is visually the highest card. And then we get the card top difference, where we subtract the max from the min. So if we had 80 as the top and then 40 as the min, we would do 80 minus 40, and that would be 40, and that would be our card top difference. And this would function to see if the card top difference is greater than or equal to the vertical stack card top difference, which we have to figure out that, which this is the pixel length between two cards vertically. The vertical pixel length between two cards. Okay. And this is for a vertical stack. So in this case, we would run the collided cards date code. this. Okay, so if this is the case, what code do we want to run exactly? Well, this was when we did the position Y distance to card top. So we know we're dealing with vertical stack here, and then now we want to determine which card we actually clicked. So there's an easy way to do this, easier than what I had coded. Couldn't we then just iterate through the collided cards list and we would compare the card top to the Y? The only question though is, like, would it work the same as with the horizontal? Because with the horizontal, it worked in such a way that the last card would always be the clicked card if we were going from like lesser to greater. But I don't know if that's true. We would have to sort the list, wouldn't we? I'm gonna have to visualize this. I'm having trouble. So if we have the hand, or whatever you want to call it. Well, actually, we have a vertical stack. So let's say we have this vertical stack here. And it's gonna look like this. Whoa, that's ugly. Let's try that again. So we have, looks like so. It would actually be more like that. That looks a lot better. So we have 1, 2, and 3. Now, if we clicked right here to pick number 2, let's say that the Y right here is going to be, we'll have the Y equals, it's going to like face up. So right here is going to be equal to Y equals, and this is going to be, let's just say this is 10. Okay, Y equals 10, and then this is going to be Y of, let's see, 50, let's just say 100. Okay, so then let's say this is 100, this is 110, and then this one is 120. Right. Now, when whenever we click this card, we have our, what's it called? The collided cards list. And it's the list of all the collided cards. So let's just say CCL. And that's going to consist of 1 and 2. Because 3 is not included. But since 1 extends all the way down here, so our collide area basically would go from here to like right here. So anything within this green box is gonna be the CCL. Well, that's not true. Let me rephrase that. The green box represents the space for card 1. And then card 2 would actually go down to here. And then card 3 goes down to like right here. But it's not included, okay? So, because the top of the card 3 makes it to where it's outside of the clicked area. But 2 is inside. And so is 1. 1 and 2 are both inside the clicked area, if that makes sense. I know it's a little bit complicated, but it's not terribly complicated. Just put a 1 over here and a 2 over here. But then we put a red 3 because this one is not in the list. Alright. With that being said, it's going to iterate through the clicked card list, or the collided cards list. But my question is, would it be populated in any particular order? You know what I mean? Like, I think how it would do that would, well, it's iterating through the order of the clickable card list. So if the clickable card list order was 1, 2, 3, then it's going to append it's going to create the collided card list in the same order as the clickable card list. So as long as the clickable card list is ordered properly, meaning from top to bottom, then that means the collided card list would be properly ordered from top to bottom. So that's important because after we get this data, we would then iterate through these cards and we would get the top value. So we'll use I guess yellow for this. We'll say this would be CTL, I guess, card top list. So we'll say card top list. And the top for card 1 would be, the top of card 1 is right here. And that's going to be 120. So it's going to have 120. Because remember, it's going to go in order that the clickable card list goes in. And the clickable card list, it's always going to be a top-down process for vertical, and then a left-to-right process for horizontal. That's just the way the game is coded. Next cards always go below for vertical, and next cards always go to the right for horizontal. So the card top list would consist of the values 120, and then 2 is going to be 110 because the top of the 2 card is right there, which is 110. Okay, it's really hard to see. Like, makes my eyes hurt looking at that. But anyway, since there isn't a third object, does the same logic apply? Does it mean that the last card in the card top list is our clicked card? We would have to test with another scenario. Let's do a different scenario. Let's make this one have a little bit more cards. All right. So we have 2, 3, or 4 cards. What's it? Well, I made them a little big, like a little bit spread out. They shouldn't be that spread out. I messed this up here. This is ugly. Let's try this again. Alright. So we have 1, 2, 3, 4, and then 5. Alright. So if we were to click right, let's click 4, right? Yeah, I don't even think I have to go through the whole process. I can just like say, if I click right here, it's gonna include, we'll draw what it will include. It will include everything from here. Well, it will include all of these cards. This card is gonna go all the way down to, like, let's just say it goes to right here. It would go further. It would go to like right here, roughly. So it's gonna include 1, right? And then 2 is gonna go all the way down here. So it's gonna, this is fucked up, man. My spacing here is messed up. Oh well, the length isn't right, but it'll work. So this is card 1. Then we have card 2, and it's gonna go down here. So it's gonna be included as well. 2. 3 is also going to be included. It's going to go down to like right here. The actual length of that card. And then 4, of course, is going to be included as well because it starts up here and it's going to go all the way down to right here. Let's try that again. Now it's not going to include 5. 5 is outside of the realm in which, you know, it doesn't fall inside. So it's not going to be included. So in this case, our CCL is going to consist of, we'll just skip the underscore, just say CCL. Consists of 1, 2, 3, and 4, and then the top list is going to be CTL, and that would consist of, let's pick a different yellow. I can't see that. We'll just use pink for this one because you can't see that color. CTL for the top list is going to have a corresponding value of 120, and then 110 for 2, 100 for 3, because remember this is the tops of the cards. So we have 120, 110, 100 for 3, and then 90 for 4, because it's the top of the card, and then 90. And if our actual click point, which is in red, our click point for this one was, let's just put the XY as being, 20, and then the Y, which is what's important here, is between 100 and 110, so let's just say 105. So in this one, it would have iterated through the CTL, and it would have went through the first 120 and then the 110, and that means that the last one is the clicked card, the last one in the clicked top or card top list. And now we can check to see if the same is true over here. So we would have iteration through the CTL. We'd start at 120, and that would check, oh wait, sorry, we have a different CP, click point. Our CP is just going to be, let's just say 20 again for the X, which doesn't matter because we're worried about the Y for vertical. And this would be, I don't know, let's say 90, let's just put 90 right here. And then this is 80. Yeah, 80 right here. Alright. So our click point would be between 80 and 90, so let's just say 83. So we have 83. Alright. So as it iterates through the CTL, it's going to start at 120, and then it's going to keep going to, it's going to go to the next one. 2 is going to be 110. And we're trying to see, we're comparing the CP index 1, which is the Y, against these card tops values up here in the CTL. And if we go in order of the, the natural order of the list, which is directly related to the order of the collided cards list, which is directly related to the order of the clickable card list. So we can be confident that that order is proper. So we keep going. We're checking to see specifically if the card top value, so we'll just put this, we'll say the CTV, which is the card top value, is greater than, let's see, put CTV, and are we checking for greater or less than? So the CTV is, as long as it is greater, because we're going from top to bottom, okay? So if it is greater, because we're starting at the top, so while it's greater, we keep going. because we wouldn't say less than. If we check to see if it was less than, well, that would never be true. And honestly, it would always be true that it's greater than, at least I'm pretty sure. So like, I'm pretty sure we could just do the same thing where we check where the click card ends up being the last of the list. I just wanted to visually make sure of this. So anyway, the CTV would be equal to, for the number 1, would be 120. So when you compare that against 83, is it greater? Yep, it's greater. So it's not this one. This isn't our click card. Then we check number 2. And for number 2, it's 110. So we keep going. Okay. We check number 3. And remember, we're checking against 83. As long as it's greater, we keep going. So now number 3 is 100. Alright. Compare that to 83, it's still greater. We go to the next one, then do number 4, which is going to be 90. We compare that to 83. It's still greater. So, long story short, it's gonna, if we go off of the logic of, okay, it's definitely not this one, and it's not this one, because the value is lesser. It's not between 120 and 110, right? It's less than both of those, so it can't be number 1. And then same thing with 110. It's not between 110 and 100, which is the 2 card. It's less than that. And it's not between 100 and 90, which is the 3 card, because we're measuring again from the top to the top of the next card. So we say it doesn't fall between this spot and this spot. It doesn't fall between this spot and this spot, and it doesn't fall between this spot and this spot. And the only other card left in the list of collided cards is the number 4. So it's just like the law of deduction. We just deduced that, okay, if it's not 1, 2, and 3, well, it's definitely 4. And that means our click card would be number 4, which is just so happens to be the last card in our list, or index -1. So we could just basically use index -1 for that click card. And it was the same over here. Number 2 for this one, number 2 was our clicked card, and it happened to be the last one in our list. And now let's just do one more, and in this one I will make it to where we'll try to do this quickly. I'm not gonna go through all the steps. I'm gonna kind of skip some steps. All I'm gonna do is draw this ugly little stack of cards. We're gonna have 1, 2, 3, 4, 5, and of course I messed it up because I suck at drawing, but that's okay. There we go. Now we're gonna draw in the 1, 2, 3, 4, and 5. Now in this case, let's say we click right here. This is gonna be the last card. Well, that's too easy, right? Because well, nope, wrong again. I was gonna say it only includes 1 card, but it doesn't. It actually would include card number 3, which would extend like way down here. I drew it badly, but it would include that card. It would also include number 4. So this drawing is terrible, but anyway, it includes 3, 4, and 5 in our collided card list. So our list would consist of 3, 4, and 5. Then we already know if we start at the top, let's say this value right here, our click point is equal to, let's say the click point is equal to 30, and then, or actually, how about this will be 40, and then 50, and 60, and so on and so forth. So we only need these 3. So our click point would be like 38. We'll just say 37. 37. So since we're going to start at the top, we're going to compare against 60, because it's number 3's card top. We know that 60 is greater than 37. Then we're going to go to the next one. We're going to say 50 is greater than 37. And then we're going to check the card top again. And the card top is going to be greater than 37. And we got to the end of our list. And again, it would be the last card in our list. It would be the 5, which is also easily referenced by index -1 without having to do any calculations. So we can just like automatically know we're dealing with index 1, -1. And yeah, that took way longer than it should have. But ultimately, it doesn't matter where we click. If we click in the middle card, if we click closer to the bottom, if we click the very bottom card, and even if we were to click the top card, I could just do this really quickly in my mind. We click here, this would be 80, 70, so the click point would be 68. We would start at the top. Is 80 greater? Well, in this case, that's an easy answer. The click card list is only going to consist of the number 1 card. It's not going to include 2, 3, 4, or 5. So like automatically these are not even included as possibilities. So you wouldn't even have to use any logic. You could just again use the -1 index of the clickable or collided cards list. Boom, done. There we go. So we know now that we can just use all we have to do is create the collided card tops. Collided card top vals list. And then we're gonna iterate through the card in the collided cards list. Or wait, we already have the card top list. And we should actually change this to be collided card top list. Yeah, that's better. So now we're going to iterate through the collided card top list, and we're going to compare it against the... Oh no, remember we already determined this. It's gonna be the last card in the collided card dict. the collided card list. We don't have to do any calculation. Like that was the whole point of the demonstration we just did, or the illustration we made rather. Illustration, demonstration, both. Uh, as long as we have the collided cards list, okay, but we do need the collided card top list to determine if it is vertical. Right, okay. So let's just review this. We create the collided cards list, we iterate through the clickable card list, we check to see if we collided with any of those cards from the clickable. If we did, we change click card to true, we append the card to the collided cards list. Then when we're done with that, we now have a fully populated collided cards list. We check the length of it. If it's greater than 1, we get the card top list. And let me put this else down here before I forget. Else, we'll say elif lane of collided cards list is equal to 1. And I'll just put what about when equals 0, because I'm just not sure about that. Anyway, so we check the length of the collided card list. As long as it's greater than 1, we create a card top list. We iterate through the collided cards list and append to the collided card top list the card rect top, which is the top of that card. Which is akin to its y value. It's the y axis value of the top of that card's edge. So now that we have a list of the top of them, we can see the max, the greatest value from that list, and the smallest value. And then if we get the difference of those two, we can check if the difference between the greatest and the least is at least the vertical stack card top difference, which is like, we'll just say 30 pixels. As long as it's 30 pixels difference, we know that we're dealing with a vertical stack of cards. So then we know we need to execute the vertical stack logic. Execute vertical stack logic. Okay. Then well, you know what? We don't have to do any logic. All we have to do in this case, we can just assign the clicked card. We know that the self-clicked card is, remember, because we figured this out through our illustration, is that for a vertical stack logic, the clicked card would always end up being the last card in the collided cards list. So we just say collided cards list -1, and that's going to in this case the self-clicked card will always be the last card in the collided cards list. And this is because it goes from top to bottom. Yeah, because like if it were going to include a next card, then that means we would have clicked low enough for the Y-val like to include that card. You know what I mean? It would have been within that card's rectangle, and then that would be the lowest card, because basically the final logic is that when you're executing vertical stack logic, the click card is always the card with the least Y value out of the collided cards. So if you have 3 collided cards, boom, boom, and boom, it's always gonna be the lowest card. All right, let me try to, because I'm doubting myself here, but I'm pretty certain I'm right, that if you have 3 cards, and that's really all we need for our demonstration. So we have 3. If we have 3 cards, and our clicked card is, let's just say it's this one, then the only cards in our clicked card list is going to be number 1. Because we didn't click inside of number 2's box, we didn't click inside of number 3's box. We only clicked inside of number 1. So it could only be 1 in this case. Now if we clicked here, we actually clicked inside 1 and 2's box, but not 3, because we didn't click low enough for it to be 3. And since it goes from the order of the clickable card list, and the clickable card list goes in the order like that the cards were appended to whatever card group we're dealing with, and that always goes from top to bottom. That means it will always be the number 2 card in this case, which is again the last card in the clicked card list. And then same thing if we do number 3, it's going to include 1, 2, and 3. But we know that based on logic, it's going to be number 3, because if there was a 4th card, you know, that would be the last card. I'm struggling to find the correct like words to describe what I'm explaining, but I think it's pretty obvious. So yeah, it's always gonna be the last card, whichever the last card is. That's your click card. Yeah. So if card top difference greater than vertical stack difference, yeah, it's that simple. So click card equals collided click cards list at index -1, because that's the last one in the list. Boom. Now, if the length of the collided cards list is equal to 1, well then we know that the self-clicked card is equal to the only card in the collided cards list, right? If it's only equal to 1, then the self-click card is equal to collided cards list at index 0. Since there was only 1 card in the group, has to be this card. And then what about if the length of the collided card list was 0? Well, didn't we have logic that said if clicked card is true? I'm gonna put above 4x 1, 2, 3, 4x lines. I think we need to include this small section in the being reworked logic. Which is a nice way of saying it needs to be reworked and included in the above section, which replaces all this. Yeah, I don't want to forget about that. Yeah, because we don't have the if click to card is equal to true right here, but we do need it. We have to have that. The question is, where do we add this line? So we'll put below line in the rework. Where does this line belong? And I think I'm done. I'm gonna take, I will finish this tomorrow. We'll just say that we stopped here. I don't want to burn myself out too bad. But yeah, so I'm really happy. I think we basically finished this. We just have to, you know, it'll take us a little bit of time, but this is really easy. Yeah, we can do the else horizontal stack checks rex instead for current card in the clickable card list. If current rect collide point event position clicked card true, last collided card equals current card. Bro, it's the same logic for both of them. I just realized that this is the same logic. It's always the last card because of the order. So like we don't even have to execute logic. All we need is the list of the collided cards, and since those are ordered either top to bottom or left to right, then we know that like if there's a, we already figured out the vertical logic, right? If there's a card below it that's included in the collide card dig, well, that's the card. Once you get to the card in which there is no other card after it, that's your clicked card. And it's the same thing with horizontal, since we always go from left to right, and that means the clickable card list would be organized from left to right, which means the collided card dict would be organized from left to right. That means the last card, the card at which there is no longer another after it, is going to be the clicked card. Same exact logic. It's just horizontal instead. Of course it's going to be the same. If you have 1, 2, 3, 4, it's the same thing. 1, 2, 3, 4. And if you click right here, you're going to include all this, but you're not going to include 4 because you didn't click inside its box. But you're just going to keep iterating through it until you get to the last one, and you know that's your card. Boom. It's like a cheat, you know, but it's not. It's just, it's the way it works. It's simple. And then if it was the fourth one, it would include all of them. Granted that number 1 is long enough, it would probably like go to like right here. or maybe like right there. So yeah, it would be included in the dot would be included in its space, and you would just iterate from left to right, boom, 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 and you know it's going to be the last one. Same thing if it's the second one, it's going to include 1 and 2. You're going to iterate from left to right, it's going to be the second one. It's always going to be the last. And then same thing if it's number 1, well that one's only going to consist of 1. So all that just to say it's always the last card of the collided cards dict. And I never realized that until just now. So we don't actually need any of this. We can get rid of all this logic, literally all of it. Because remember, we're only dealing with collided cards. We don't have to worry about the clickable. Clickable is irrelevant. If the length of the collided cards list is greater than 1, the click card is always going to be the collided cards list at -1. Bam. Then, else, it's going to be click card is going to be collided cards list at index 0. Wow. I just feel like there's no way that's true. There's no way that's true, bro. There's no way I went through this entire project this far and just now realized that there was that little trick to calculate that. Damn. No way, huh? Here's what I'll do. I'm gonna undo all this real quick, and I'm gonna copy the section before I touched it, just in case I'm wrong, because it is late in the day. Maybe I'm being stupid, but I wanna. Damn. So that's the section right here. What we'll do is copy this. So all that gets copied. Fast forward, and this is from click card to self event handler start time is equal to none. So this is from clicked card false to the event handler start. Clicked card false to the event handler start. Right. So click card false all the way to event handler start. Oh well, I already had it copied. I'm dumb. let's just review. Event type, power game mouse button down, click card active is true. Click card equals none, click to card equals false. Create the collided cards list. We then iterate through clickable card list to see if we have a collide point for each card. If we do, we change click to card to true. We append the collided card to the collided card list. We then check to see if the length of the collided card list is greater than 1. If it is, we know click card is equal to collided card list at index -1, which is the last in the list. Else, click card is going to be equal to collided card list at index 0. And then we say if click to card is equal to true, which it would be in this case. We check to see if click card is equal to none, and as long as it is, then we say clicked card equals self collided cards dict. Well, actually this is wrong. We don't need that anymore. All we need to do is move this up here. To check if clicked card is true. Then we check to see if clicked card is equal to none. We would then this needs to go up here. This would be only if click to card is true do we want to print out the collided cards dict, and only if clicked card is also equal to none would we want to execute all of this code. Yeah. So we need to remove collided cards dict completely. We're not going to use that at all. Okay. Cards equal to none, click card equals false, collided card list, iterate the clickable card list, for collision, click card true, collided card list append card. Check if click card is equal to true. If so, click card is equal to none. We can do and. We can say and click card is equal to none. And I'm going to put a note here. Do we need the latter section which checks? So, alright, and then if that is true, we would print out the collided cards dict as just a log. Then if the length of the collided cards list is greater than 1, we would make the click card equal to collided cards list at -1. Else, which means the length of it was only 1, click card would equal to collided card list at index 0. Yeah. And then we have this event handler stuff which needs to be like included, but we can fix that. Finish the rest of this section to conform to replacement logic. this to be connected to lower portion. Alright, yeah, and that's where we stopped. And now we're just gonna go to do devlog. It's 7:30, and we'll just say we did. That's an hour and a half. Okay, so we did another hour and a half. And 5:55 to 7:32, which was 4.75 hours total. Alright, we'll put finished implementation of, or almost finished implementation of reworked click card logic. Stopped at line number 1000 in game 5. Yeah, buddy. Alright. We'll copy. We're actually going to stage and commit the changes again for the second time today. 7:31 to 7:33. And I do like my numbers to match up here. So we'll copy this entirely. We'll do git branch to ensure we're on the right branch, which we are. Git add to add everything. Git commit -m double quotes paste double quotes to close. Git push Canasta secondary to push to the remote repo. And that did that. Now we can go ahead and go to programming projects, go to Canasta, copy this, back out, delete the old backup, paste in the new one, and enter into it. Go into text, devlog, go all the way to the end, and we do have the correct log. So now we can, oh, that's already been done today, so we don't have to modify that. Alright, that's that, dudes. Y'all have a good one, and I'll see you next time.